Hello everyone, I am Mr. Tariq and now I will help you to overview lesson today about applications on derivative. We studied before the roots of derivative to find the first degree, and we know that the slope of a tangent is the first derivative. So the slope of the tangent of y equal f of x at points x1 and y1 lying on it. Dy by dx is the first derivative at point x1 and y1. So tan theta equal dy by dx. Now we will talk about the tangent to the curve. As we know the slope of the tangent, we know that the slope of the tangent is the first derivative, or tan theta. So if you have two line parallel, so their slopes are equal, and if you have two line perpendicular, the multiply of two slopes equal -1. So the slope of the tangent is, for example, first derivative dy by dx. So the slope of the normal is the perpendicular to the tangent, and the curve is -1 over dy by dx at point x1 and y1. We can get the slope of the tangent from the equation of the straight line in general, ax plus by plus c equals 0. The slope equal negative coefficient of x over coefficient of y. So our lesson about application on derivative. We must know the slope of the tangent equal dy by dx at the indicated point x1 and y1, or tan theta, which make an angle with positive direction of x-axis, or y2 minus y1 over x2 minus x1. If I give you 2 points, or negative coefficient of x over coefficient of y, if I give you the equation of straight line in general. And if you have two line parallel, L1 parallel L2, their slopes are equal, M1 equal M2, and if you have L1 perpendicular to L2, so M1 multiply M2 equals to -1. The equation of the straight line, we can get it from the rule y equal mx plus c, or as we studied before, the equation of tangent is y minus y1 equal slope times x minus x1, and the equation of the normal which is perpendicular to the tangent is y minus y1 equal -1 over m times x minus x1. The first question here is find the points which lie on the curve y equal x power 3 minus 4x plus 3, at which the tangent make with the positive direction of x-axis an angle of measure 135. So first I will find the derivative of the function, so dy by dx equals to 3x power 2 minus 4. The slope of the tangent dy by dx at the indicated point, we not have a point but we have an angle, so tan angle give me the first derivative or the slope of the tangent. So tan 135 equal -1. So 3x power 2 minus 4 equals to -1. So 3x power 2 equals 3 and x power 2 equals to 1, so x equal positive or negative 1. At x equal 1 we must find the value of y, and x equal negative 1. To find the value of y, substitution in the function. Y equal 1 power 3 minus 4 times 1 plus 3, and y equal negative 1 power 3 minus 4 times 1 times negative 1 plus 3. So this value will be 8 and this value will be 0. So the first point is 1 and 0, and the second point is negative 1 and 8. Another example, find the points which lie on the curve y equal x power 2 minus 2x plus 3 at which the tangent to the curve is parallel to x-axis. The curve parallel to x-axis, so the slope of the curve equals to 0, and if the tangent parallel to y-axis, the slope is undefined. So we have here the slope equals 0, so dy by dx equals 0, and here perpendicular to the straight line we must get the slope of this line is, for example, m2 negative coefficient of x over coefficient of y, which equal 1 over 4. So dy by dx here, or our slope, equals to reciprocal of 1 over 4 times negative 1 equal negative 4. So first find dy by dx of the function equal 2x minus 2. First 2x minus 2 equals to 0. So 2x minus 2, so 2x equal 2 and x equals to 1. Take one substitution in the function, so 1 power 2 minus 2 times 1 plus 3 equals to 2. So the point is 1 and 2. The second one is 2x minus 2 equals to negative 4. So 2x equal negative 4 plus 2 equal negative 2, so x equal negative 1 by substitution. So y equal negative 1 power 2 minus 2 times negative 1 plus 3. So the value will be 1 power 2 plus 3, 4 plus 2 equals 6. So the point will be negative 1 and 6. Another example, find the measure of the positive angle which is the normal of the curve. The normal of the curve. Y equal root 2x power 2 plus 7. So we have the function and we must find the angle which is a normal make with the positive direction of x-axis at the indicated point negative 3 and 5. So dy by dx, first y equal 2x power 2 plus 7 all power 1 over 2. So dy by dx equal 1 over 2 times 2x power 2 plus 7 all power negative 1 over 2 times the first derivative of the inner function will be for x. By substitution about x equals 3 and negative 3, sorry, so the slope of the tangent, which is equal to m, will be 1 over 2 times 2 times negative 3 power 2 plus 7 all power negative 1 over 2 times 4 times negative 3. So the result will be 1/2 time 2 times 9 plus 7 all power negative 0.5 time negative 12. The result will be negative 6/5. So the slope of the normal is right 5/6. So tan theta equal 5/6 shift tan 5/6 equal 39 degree and 48 minutes and 48 minutes. Another one, find the equation of tangent and normal of the curve y equal x plus 3 over x plus 1 at the point lying on the curve and whose abscissa equals to 1. Abscissa is the intersection with x-axis at x equal 1. This is the abscissa. The abscissa, the intersection of x-axis. So dy by dx, first derivative, equal x plus 3 over x plus 1 power 2. We will take the rule of division is the denominator time derivative of the numerator is 1 minus the numerator x plus 3 time derivative of the numerator is 1 all over the denominator power 2. By substitution about x equal 1, so it will be the slope of the tangent is 1 plus 1 equal 2 times 1 minus 4 times 1 over 2 power 2. So the result will be negative 2/4 negative 1/2. This is the slope of the tangent. So at x equal 1 we must find y. The value of y equal 1 plus 3 over 1 plus 1 equals to 2 equals to 2. So the point is 1 and 2 and we have the slope negative 1/2. So the equation of the tangent is y minus y1 time equal m time x minus x1. By substitution about y1 and x1 and m, so y minus 2 equal negative 1/2 times x minus 1. The equation of the normal is y minus y1 equal negative 1/m times x minus x1. So y minus 2 equal negative 1/m negative 1 over negative 1/2 equal to 2 times x minus 1. This is the equation of the tangent and this is the equation of the normal. Another one, find the equation of tangent and normal to the curve y equal x sine 2x at the point pi/4 and pi/4. We have the point, so I will find the first derivative first. So dy by dx equal x sine 2x, the first, time derivative of the second is 2 cosine 2x plus the second sine 2x time derivative of the first is 1. By substitution about x equal pi/4, so the slope of the tangent equal pi/4 times 2 cosine 2 times pi/4 plus sine 2 times pi/4 time 1. This value will be 0 and this will be 1, so the slope equals to 1. And we have a point pi over 4 and pi over 4, so the equation of the tangent will be y minus pi over 4 equal m1 time x minus pi over 4. This is the equation of tangent. And the equation of normal, y minus pi over 4 equal negative 1 over m, negative 1 over 1 equal negative 1 time x minus pi over 4. This is the equation of normal. Another example, find the value of two constants a and b if the slope of the tangent of the curve y equal x power 2 plus ax plus b at point 1 and 3 equals to 5. So we get a point 1 and 3, substitution about the point first, so 3 equal 1 power 2 plus a time 1 plus b, so it will be a plus b equal 2. This is the first equation. The second one, the slope of the tangent equals to 5, so the first derivative dy by dx equal 2x plus a equals to 5 at the x equal a, at x equal a, at x equals to 1, at x equals to 1, dy by dx equal 2 times 1 plus a, which equals to 5. So 2 plus a equals to 5, so a will be 3 by substitution in the first equation. So 3 plus b equals to 2 and b equals to negative 1. Another example, so we have here, if the tangent of the curve, so if the tangent of the curve of y equal 4 over x at point C at the first quadrant intersect the two coordinate axes at 2 points M and N, prove that the area of MON is constant and doesn't depend on the position of the point C lying on the curve. So we have 2 points M and N, and the equation of the curve y equal 4 over x. So y equal 4 over x, we can write it as 4x power negative 1, and the derivative of the function dy of dx equal negative 4x power negative 2. At point C x1 and y1, we can get the slope of the tangent. So the slope of the tangent is negative 4x1 power negative 2. The intersection at M is at x and 0, and here at 0 and y, y2 and x2. So we can get the equation of the tangent. So the equation of the curve is, the equation of the tangent is y minus y1 equal m times x minus x1. The point x1, y1 by substitution in the curve, so y1 equal 4 over x1. This is the value of y1. So y minus 4 over x1 equal m times, m is 4, negative 4 x1 power 2. Time x minus x1 negative 4 x1 minus power negative 2. So multiply all the equation by x1 power 2. So here you will find that x1 power 2 y minus 4 equal negative 4 times x minus x1. Distribution negative 4. So x1 power 2 y minus 4 equal negative 4x plus 4x1. So the equation of the tangent is x1 power 2y plus 4x minus 4x1 equals to 0. The intersection with x-axis at the first point x2 and 0 by substitution about x equal x2 and y equal 0. So x1 power 2 times 0 plus 4x2 minus 4x1 equals to 0. So this part will be cancelled. So x2 will be 1 plus x1. This is the value of x2. And the intersection with y-axis at 0 and y2. So by substitution on the equation of the straight line, so x1 power 2 y2 plus 4 times 0 is 0 minus 4x1 equals to 0. So this will be cancelled. So y2 equal 4 plus 4x1 all over x1 power 2. The area of the triangle equal half time base time height. So this distance is x2 and this distance is xy2. So the area is half time area of triangle equal half time x2 times y2 by substitution. So half time x2, which is 1 plus x1, plus y2 is 4 1 plus x1 over x1 power 2. So it will be half time 2 equal 2 1 plus x1 power 2 over x1 power 2. This is the area of we have a mistake here at multiplying by x1 power 2. This is x1 power 2y minus 4x1 this is negative 4x1 minus 4 times x1 minus x1. So you will get this is 4x1 and this is will be positive 4, so it will be positive 8 or negative 8x1. So this value will be negative 8x1 negative 8x1. So if you substitution about y equals 0, so for x2 minus 8 minus 8x1, so x2 will be 2x1 and here at y2 and 0 and y2 the value here will be 0, and this will be 8x1. So this will be minus 8x1. So a y2 will be 8x1 over x1 power 2, which equal 8 over x1. And the area will change to half time 2x1 time 8 over x1. So x1 will cancel x1 and 2 will cancel with 2, so it will be 8 unit square. So the area of the triangle not depend on x1 or x2 or the point C. This is the mistake on the problem. So let we move to another one. Find the surface area of triangle formed from x-axis and the tangent and the normal to the curve y equal x power 2 minus 6x plus 13, add 4 and 5. So the derivative of the function dy by dx will be 2x minus 6. So the slope at the point at x equal 4. 2 times 4 minus 6, which equal to 2. This is the slope of the tangent at this point. So the equation of the tangent will be y minus 5 equal 2 times x minus 4. So y minus 5 equal 2x minus 8, and y equal 2x minus 3. And the equation of the normal is y minus 5 equal negative 1 over 2 x minus 4. So multiply by 2, so 2y minus 10 equal negative x plus 4. So the equation will be 2y equal negative x plus 14, or we can write it negative 1 over 2x plus 7. This is the equation of the normal. And the area between x-axis and the tangent and the normal, we can draw it on GeoGebra. Y equal the first one, y equal 2x minus 3. This is the first line, and the second line is y equal negative half x plus 7. Negative 0.5 x plus 7. So we have here the height. The height is 5. The height of the triangle is 5, and the base is from 1.5 to 14. Is the distance here 14 minus 1.5 equals 12.5, and the height is 5. So the area of triangle equal half time 12.5. The distance between 14 and 1.5 is 12.5 time the height is 5. So the answer will be times 12.5 times 5. The result will be 31.25. unit square. This is from the GeoGebra program. We can solve it manual by find the point of intersection of x-axis and y-axis to the tangent and to the normal at x equal 0, so y equal -3, and at y equal 0, so x will be 3/2, and here at x equal 0, so y equals 7, and at y equals to 0, so x will be is 14. And the point of intersection of the tangent and the normal, solving the two equations by substitution, y equal to x minus 3, so 2x minus 3 equal -half x plus 7, so multiply all value by 2, or take half x to the other side and the -3 to the other side, so 2.5x will be 10, so x will be 4 by substitution here, so y equal -half times 4 plus 7, which equal to half times 4 times 7, which equal to 5. So the intersection point is 4 and 5. So if you draw, this is y-axis and this is x-axis, and the tangent is at point 0, -3, and 0 and 3/2, 0 and 3/2 here, and 0 -3 will be here. This is the tangent to the curve, and the normal of the curve 3/2 and 0, and the normal is at point 0 and 7 and 0 and 14, 0 and 14 for example here, and 0 and 7 will be here. So this is a straight line. The intersection here at 14 and 0, and here at 7 and 0 and 7. And here 0 and -3. The intersection point between the two lines is at 4 and 5. So we will find the area of the triangle is here. The base is 14 minus 3/2 equal 12.5, and the height will be 5. This is the last question. Thank you very much and see you later.